in Civil Department, working in Emmanuel Research JJ College of Engineering, Natala. Today we can discuss about Kelvin Theorem. Kelvin Theorem introduction. Kelvin Theorem, circular theorem, state that the invisible barometric fluid with the conservation body force, the total circulation closed curve moving with the fluid remains constant over time. That means the closed curve moving the fluid remain over time constants. In aerodynamics, it explained that because fluid is the rest zero. Airfoil creates the equal and opposite bonding circular. The airfoil is entered total circular remaining zero. Kelvin's circularization theorem. Definition. The theorem focuses on a metal contour, a loop formed by the same set of fluid particles as they move. Condition. Required ideal. Barometric fluid is pressure constants. Conservation body is like gravity. Gravity due to the acceleration is constant value, that is 9.81. Vorticity conservation. If a fluid is initially in rotation, it will remain in rotation, means it cannot start rotation without viscosity effects. Aerodynamic lift, that means aerofoil acceleration from rest. The Kutta countries create a starting vortex. According to Kelvin theorem, a bonding vortex to equal strength and opposite sign must be developed. That means statement. Kelvin's circularization theorem that there is conservative body force, the moving with a fluid remains constant with time. Mathematically, if tau T equal to delta Cu into di is the circulation around a closed curve where C is the moving with the fluid, then dt equal to d torque equal to 0 where U is the velocity field of the fluid. Proof. Given fluid is invested, no viscosity. Fluid is barotropic pressure, P is the function of density, rho only, that is P equal to rho. Body force or conservation give the gravity, so body force per unit mass F equal to minus del pi for some potential pi. To prove dt d del Cu into di equal to 0, where C is the closed metal car moving with the fluid. Step 1. Define circularization. We find circularization around a closed curve. C is torque equal to del Cu into di, where di is the element of the car. Metal derivation of circularization. The time rate of the change of circulation following the fluid motion. Dt equal to d torque equal to dt d delta Cu into di, where C moving with the fluid, both U and di depend on them. C is the moving of with the fluid. Using Reynolds transform theorem for line integral dt into d del Cu into di equal to del C into bracket open dt into du into di plus U into dt into d di. But the methods derived from of the line element moving with the fluid is dt into di equal to du, because the line elements change as the fluid particles move. Therefore, dt equal to di equal to del C dt du into di plus u into du. Step 3. Similarly, second term, note that u into du equal to 21 du plus u. Therefore, u square. U into u square. Since C is the closed curve, the integral of an extracted differential over C is 0. Therefore, del CD equal to 2u square equal to 0. Thus, dt d tau equal to delta C dt into du into d. Step 4. From Euler's equation of motion, Pressure force in the direction of flow. Second part, pressure force P plus dou P by dou S into ds into dA opposite to the direction of flow. Step 3, weight of the elements dou G dA into ds. Let theta means the angle between the direction of flow. Rho in the density of the fluid. G is the acceleration due to the gravity. Therefore, P into dA minus P plus dou P by dou S into ds into dA minus rho G dA into ds equal to cos theta. Therefore, we can consider Euler's equation P plus into dP by P into G into dz by V into dV equal to 0, where V into velocity of the fluid. F equal to minus del pi is the body force per unit mass. Substituting into the integral, therefore we got dt into d top equal to del C into minus rho 1 del P minus del pi into di. Therefore, we can written minus del Cp1 del P into di minus del C del pi into di. Step 5. Evaluate the integral. Since pi is the scalar potential, del pi is the graduate field, so del C pi into di equal to 0. For a barotic fluid, P equal to dou P. Define P rho 1 del P equal to del H. We can written del H equal to rho 1 into del P. Therefore, integral Cp1 del P into di equal to del C del H into di equal to 0. Step 6. Conclusion. Since both integral vanish, dt by d tau equal to 0. This proves that the acceleration around a closed metal curve moving with the fluid remains constant in time. Thank you.